Hi, welcome to Orozco's Lectures. I am Jose Orozco, and these are my lectures. This lecture is a pre-calculus lecture. I hope you enjoy it.
This is section 4.8, which is on applications and models of trig. All right, so let's start by solving a triangle. All right, and when we're talking about solving a triangle, we usually work with right triangles. So let's go ahead and draw a right triangle. And there we go. So here's my right triangle. I'm going to say here this data is equal to 20 degrees. That's at vertex A. Here's vertex B. Here's vertex C. Actually, let's write it differently. I'm going to call this one up here vertex B and the right angle vertex C, giving us that I'm going to name the opposite side of vertex A, I'm going to name it side A. Opposite side of vertex B, I'm going to name it side B. And opposite side of vertex C, I'm going to name it side C. Notice I used uppercase for the vertices and lowercase for the sides. Now, let's say that B was equal to 15. The idea here is, well, when we solve a triangle, we want to figure out what the rest of the angles are, as well as what all the sides are. First, let's see what we can figure out. We have this angle theta over here at A to be 20 degrees. Now, we know that the sum of all the inside angles of a triangle, they must add up to 180 degrees. So in other words, angle A plus angle B plus angle C is supposed to be equal to 180 degrees. We know angle A to be 20 degrees. Let's write that better, 20 degrees. We don't know what angle B is, but we do know angle C is a right angle, so that angle must be 90 degrees. So solving for angle B, we get, well, 180 minus 90 and then minus 20. That gives us 70 degrees. All I did there was subtract both sides by 90 as well as by 20 degrees. And we've got the other angle. Cool. So that was the easy part. Now let's look at the sides A and side B. All right. So that was one answer. Side A and side B. Well, let's base it off of the angle that was originally given to us. Based off of this angle, if I ignore, for example, side C for now, then I can use trig to relate this angle with this side and this side, all right? In trig, relating to this angle, this would be the opposite side and the adjacent side. So we know that tan theta is equal to the opposite over adjacent. In this case, this means that tan of 20 degrees is equal to the opposite side, A, over the adjacent side, B. And from there, we can figure out some stuff. We know what side B is. Side B is 15 units, whatever that is. Could be centimeters, meters, whatever, it's 15. So what we can say here is that tan of 20 degrees is equal to A over 15, meaning that A is equal to 15 tan of 20 degrees. All right. Now you want to make sure to use the information here, this tan of 20 degrees. When you plug it into the calculator, you want to make sure two things. One, that your calculator is in degree mode, and two, that you're using the correct value there of tangent. All right, and you don't want to round anything off until the very end. So when I plug this 15 times tangent of 20 degrees into the calculator, I end up with the value of 5.459553514. All right, now in our instructions, it didn't say what to round it off to. So I'm going to round it off to 2 decimal places and say this is approximately equal to 5.46. All right. Now, that was side A. We still need to figure out side C. Now, you could think here that we are able to use the Pythagorean theorem, and technically you'd be correct, all right, because now we've got 2 sides, and all we need to do is solve for the third, and we are working with a right triangle. However, I would recommend that in problems like these, you stay away from using values that you found throughout the problem in case you made some mistake. That's assuming you can actually work around it. All right, so for example, in this case, I can work around it because based off of this angle, I can relate these 2 sides, in other words, ignoring side A, I can relate these 2 sides as the adjacent and the hypotenuse. And from SOHCAHTOA, we know that cosine of theta is equal to adjacent over hypotenuse. So this would tell us now that cosine of 20 degrees is the adjacent side, which we need to be 15, over the hypotenuse, which was C. If I take the reciprocal of both sides here to solve for C, I end up with 1 over cosine of 20 degrees is equal to C over 15, which tells me that C is equal to 15 divided by cosine of 20 degrees. All right. And here again, you need to be careful when plugging this into the calculator, because your calculator has a button that says this, but that says cosine inverse. All right. This is not secant. In other words, it is not 1 over cosine. So do not use that button. Use regular cosine. So what we're going to say here is, all you're going to do is take 15 and divide it by cosine of 20 degrees. And again, make sure you are in degree mode. And at that point, this gives me 15.96266659. And again, this problem didn't tell me what to round up to. So I'm going to say this is approximately 15.96. I'm just rounding to 2 decimal places. All right. And there you go. We have solved this triangle because we figured out all the sides and all the angles. All right. Now let's do this similar idea, but with a word problem. So, B. A ladder is 16 feet long and leans against a wall or against the side of a house. The angle of elevation of the ladder, so by that I'm talking about of the ladder from the ground to the wall, the angle of elevation of the ladder is 80 degrees. The question here is, find the height from the top of the ladder to the ground. All right, so I'll read it again. It says a ladder is 16 feet long and leans against the side of a house. The angle of elevation of the ladder is 80 degrees. Find the height from the top of the ladder to the ground. So the very first thing we want to do here is draw a visual. So what do we have here? We've got a house. All right, so this is my awesomely drawn house. Now, along this house, we've got a ladder leaning on it. All right. Notice here that this builds a right triangle right there. This ladder, what do we know about this ladder? This ladder is 16 feet long. So that would be this distance, right? That's the distance of the ladder. What else do we know? We know this angle right here, because right here, that would be the angle of elevation. And we're told that that is 80 degrees. All right. So essentially what we've got here is just a triangle, if I just look at this piece right here, we've got this triangle. Let's draw that better. We've got this triangle, and down here it's 80 degrees. Over here this is 16. And the question is, what is this height, right? Because the question was, what is the height from the top of the ladder to the ground? So that is the height there that we're looking for. And from SOHCAHTOA, if you're trying to relate these two sides with this angle, well, we have the opposite and the hypotenuse that we're trying to relate to that angle. So what we're going to say here is that, well, we know that sine theta is equal to the opposite over hypotenuse. So this is going to tell me the sine of 80 degrees is equal to the opposite, I'm going to call that x, over the hypotenuse, which is 16. So our x value, the height here, would be 16 times sine of 80 degrees. And again, when you go and plug that into the calculator, make sure that you are in degree mode. All right, so 16 times sine of 180 gives us 15.75692,405. And I'm just going to round that off to 2 decimal places to 15.76. And what were the units? Well, this was 16 feet long, so we're working in feet. So 15.76 feet. All right. Next one. This is another word problem. So, example C. At a point 65 feet from the base of a church, the angles of elevation from the bottom and the top of a second story window are 35 degrees and 45 degrees respectively. The question here is, find the height of the window. All right, so again, let's start by drawing a visual. First, I'm going to reread what it says, and it says, at a point 65 feet from the base of a church, the angles of elevation from the bottom and top of a second story window are 35 degrees and 45 degrees respectively. Find the height of the window. All right, so we've got some church or some building of some sort here, and let's go ahead and draw that visual. Oh, that was supposed to be a straight line. There we go. So here is the church, and we've got some window up here. All right, we've got this window. Here's the door. Now in here, what it's saying is that when we're 65 feet away from the church, we've got two angles of elevation. All right, so let's say that this is the top of the window, this is the bottom of the window, and here this is 65 feet away. All right, so what we're going to do here is we're going to look at two triangles. All right, we've got this triangle and that triangle. Perhaps I'll color code this. So we've got this triangle in here, and I'll erase the extra lines there. And we've also got this triangle out here. All right, so we've got the two triangles there. All right, so what I'm going to look at here is, well, let's go ahead and look at each of those separately. All right, so if I look at the blue triangle, what do we have? We've got this triangle, right? Where this is 90 degrees. And what do we know about this one? This is the one that goes to the bottom of the window. The bottom of the window is, so it says from the bottom and the top. So the bottom one is at 35 degrees, right? Because we need to do this respectively. So this right here is 35 degrees. And let's draw that in a different spot. This right here is 35 degrees, that angle. This distance right here is 65 feet, all right? And now, let's look at the yellow triangle. The yellow triangle has got, and you know what, let me actually move this. I'm gonna move this down here. The yellow triangle looks as follows. So the yellow triangle is something like this, right? Where this right here is a 90-degree angle, and we're looking at this distance right here also being 65 feet, but now this angle, what was it? It was 45 degrees. So that angle right there is now 45 degrees. Now, what are we really looking for here? Well, what we're looking for is the height of this window. And I'll color coordinate this differently. There we go. So we're looking for the height of this window. Notice this height of this window, the top of it is at the top of this yellow height. The bottom of it would be at the top of the hidden blue height there. That was awfully, there we go, better. So that would be the bottom of the window, whatever that height is. So the actual height of the window is going to be the yellow height minus the blue height. What am I saying here? So what I'm saying here is that the yellow height that we have here is this distance, and I'll call that A. And then the blue height that we have here is this distance. Well, let's draw that a little bit better. Maybe inside here. That's B. And what we really have is that the height H is equal to A minus B. All right. And that's what we're going to be working with here. All right. This is side B and this is side A. So to figure out the height, we got to just figure out what each of these sides are separately. So let's work with the blue triangle first. In here, since I want to relate the sides that I'm given with the angle that I have, I'm going to say, well, based off of this angle, we've got the opposite and the adjacent. Opposite and the adjacent. So we know that has to be tangent, because tan theta is opposite over adjacent, right, from SOHCAHTOA. So what this tells us now is that tan of 30 degrees would be the opposite side, B, over the adjacent side, 65. So B is equal to 65 times tan of 30 degrees. All right. At this point, I'm going to advise you to stay away from the calculator. You don't want to round anything until the very end. So you don't want to actually round stuff until you've got your final result. Let's go to figure out A. Similarly here, well, I've got the opposite side and the adjacent side. So this tells me that I'm going to be working with tan theta again because it's opposite over adjacent. So this tells me that I've got tan of 45 degrees is equal to the opposite side, A, over the adjacent side, 65. So that A is equal to 65 times tan of 45 degrees. All right. Now, oh, hold on. When did this become 30? Should have been 35. 35. There we go. Way better. Things work out much better when you have the correct information. But anyway, so now we know that H was equal to A minus B. So we're going to get 65 times tan of 45 minus 65 times tan of 35. All right, we could simply rewrite this if I factorize 65 as 65 times tan of 45 degrees, minus tan of 35 degrees. And plugging that into the calculator, this entire thing, as written, make sure to use parentheses. So I'm going to write it as 65 parentheses tan of 45. Make sure you're in degree mode. Minus tan of 35. And again, make sure you're in degree mode. And this gives us 19.48 651,002. All right. So rounding this off, I'm going to say this is approximately 19.49, and this was in feet. All right, because all the units were given in feet. So the height of the window that we just found was 19.49 feet. All right. And again, notice how what we needed to do was come up with triangles and look at each of those triangles separately. All right. All right. Let's do another one. So it was what? Example C. So example D. And it says the following. A person wishes to measure the height of a mountain. All right. He finds that the angle of elevation of the top of the mountain, or to the top of the mountain, is 30 degrees from some distance to the mountain. When he walks 100 meters towards the mountain, the angle of elevation is 35 degrees. All right. Find the height of the mountain. All right, so I'll read that again. It says, a person wishes to measure the height of a mountain. He finds that the angle of elevation to the top of a mountain is 30 degrees from some distance to the mountain. When he walks 100 meters towards the mountain, the angle of elevation is 35 degrees. Find the height of the mountain. All right, so here we go. The very first thing that we're going to do here is we're going to go ahead and draw a visual. All right, so let's get our mountain drawn. So this is our awesomely drawn mountain. All right. Now, on this mountain, or of this mountain, we've got some information. We know that the angle of elevation from some distance to the top of the mountain, this angle right here, what was it? It was 30 degrees. Right, so this one right here is 30 degrees. What else do we know? We know that this person walked closer. And when they walked closer, they found that the angle of elevation to there, let's make that a straight line. The angle of elevation to there, that same spot, this angle was 35 degrees. And that was after walking 100 meters. All right, so the question is here, what is the height of the mountain? right? And notice that I made two right triangles again. I made this blue right triangle, and it's implied the yellow triangle around this way, all right? So let's look at both of those triangles separately. So here's the yellow triangle. So we have, let's draw that better. Oh no. A right angle. There we go. Way better now. So we've got this right triangle where this angle right here is 30. We don't know what h is. All right. Then we've got this blue triangle that is actually shorter. So it should be something like this. Let's make that a nice right triangle. All right. So we got this triangle where this angle now is 35 degrees. And we're looking for this height. But what else do we know? Well, let's say this. Let's say that I name this distance right here x. All right. Meaning that in the blue triangle, this side right here would be x. And in the yellow triangle, this side right here would be x plus 100. And it's x plus 100 because it would be this entire distance, right? This 100 plus x, this entire distance. All right. So now that we've got that, we've got all the information that we really need. So let's go ahead and solve this. Well, from the yellow triangle, I got to figure out what h is. I got to relate these two sides with this angle somehow. I've got the opposite. I've got the adjacent. So I'm going to use tangent. So I'm going to use tan theta being equal to opposite over adjacent. So that tells me that tan of 30 degrees is h over x plus 100, which yields that h is equal to x plus 100 times tan of 30 degrees, all right? And I'm just going to write that as x tan 30 plus 100 tan 30. All right. Now, in the other one, in the other triangle, in the blue triangle here, I still got to relate the opposite and the adjacent side, so I'm going to use tangent again. And I'm going to say now, well, from this information, that tangent of 35 degrees will be the opposite, h, over the adjacent, x. In other words, h is equal to just x times tan of 35. So what is this going to give us? Well, I've got h being equal to this statement and h being equal to that statement. So I can set these two equal to each other to solve for x. Once I've got x, I can plug it into either this one or this one, into either of these equations, to figure out h. So let's go ahead and solve for x. So we're going to say here, since I'm going to set these two equal to each other because they're both the same height, I'm going to say that x tan of 30 degrees plus 100 times tan of 30 degrees is equal to x times tangent of 35 degrees. Putting all the x's on one side and all the non-x's on the other, I end up with x tan of 30 degrees minus x tan of 35 degrees is equal to negative 100 tangent of 30 degrees. Factoring out the x, I'm left with x times tangent of 30 degrees minus tangent of 35 degrees. And that's a 35 degrees. There we go. Is equal to negative 100 tangent of 30 degrees. Meaning that x would be equal to simply negative 100 tan of 30 degrees over tan of 30 degrees minus tan of 35 degrees. We could really rewrite this as just positive 100 tan of 30 over tan of 35 minus tan of 30. All right. Essentially, I put this negative to the bottom and replace or exchange sides here, right? And then, in other words, negative of a minus b is equal to b minus a when I distribute it. All right, so that's essentially what happened at the bottom here. All right, now, so that's my x value, whatever that is. All right, now, like I said earlier, you don't really want to start plugging things into the calculator until you're already working with your final result, right? So what I'm going to do here is I'm going to use this blue version to, oh, then I meant to erase it. I'm going to use the blue version to figure out what h should be, all right? So I've got my value of x, and I need to multiply it by tan of 35 degrees. So what I have here, so I'll just remind you, maybe I'll change colors. We have that h is equal to, what was it? H over x, excuse me, x tan 35. X times tangent of 35 degrees. But we know what x is. X is right here. So we're going to have 100 times tan of 30 over tan of 35 minus tan of 30 times tan of 35 degrees. All right. Really, this is technically over itself that way, but because we're multiplying fractions, we could just put it all over the same fraction this way. All right. And now that's what I'm going to plug it into the calculator. And you need to be very careful with this, all right? Essentially, what I'm going to do is I'm going to use parentheses on top divided by parentheses on bottom, all right? When you plug it into the calculator, parentheses are your friend. So I have parentheses 100 times tangent of 30, make sure you're in degrees, and then that times tangent of 35, again, make sure you're in degrees, close the extra parentheses, divided by parentheses tangent of 35 degrees minus tangent of 30 degrees, and close the extra parentheses. And that is going to give me a value of 329.05257778. And I can say that's approximately just 329.05, and we were in meters. All right. So the highest point of the mountain there, or the height of the mountain, would be 321.05. And again, notice that I didn't actually plug this into the calculator to figure out x. I plugged it in after into the h itself. All right, I plugged in this final result. All right. Now let's talk a little bit about something called harmonic motion. So that was example D. All right. So simple harmonic motion. And let's define what this is talking about. So a point that moves on a coordinate line is said to be in simple harmonic motion when its distance d from the origin at time t is given by either d is equal to a sine b of t, or d is equal to a cosine b of t, or bt, excuse me, cosine of bt. A sine of bt, a cosine bt. There we go. Where a is or where a and b are real numbers, and b is strictly greater than 0. The motion has amplitude equal to the absolute value of A, and period equal to 2 pi over B, which also means that this implies that the frequency is equal to B over 2 pi. All right. Notice something here, that the period and frequency are reciprocals of each other. All right. So we can say the period is equal to 1 over the frequency. All right. So that is in general the definition of harmonic or simple harmonic motion. It's going to be essentially a sine wave or a cosine wave with some amplitude, some period, and the period implies some sort of frequency as well. So let's go ahead and do an example. So I am at E, I believe. And it says find a model. That's not how you spell model. Find a model. There we go. For simple harmonic motion that satisfies the following conditions. We're given that the distance is equal to 0 at or when c is equal to 0. All right. Not just that, we're told the amplitude is equal to 6 centimeters, and the period is 3 seconds. All right. After we find the model, then we're going to find the frequency. All right. So let's go ahead and see what we can do here. All right. Now, we're going to start by writing down all the information that we've got. We've got that the amplitude is 6. So that tells us the absolute value of A is equal to 6. Technically speaking, that tells us that A is either equal to positive 6 or negative 6. Either one of those two would be correct here. What else do we know? We know that the distance is 0 when time is 0. Oh, excuse me. How is that helpful? Well, let's think about our two options. We're either working with sine or with cosine. If t is 0 here, right, then this entire thing inside here is 0. And then sine of 0 is 0. So 0 times a is 0. So d is equal to 0. So that would work here. Would that work here? Let's see. Plug in 0. So b times 0 is 0. Cosine of 0 is 1. 1 times a is a. So we will end up with the value of d equals a. So that means that we cannot be working with that one. We must be working with sine. So what we're going to say here is that these two imply that our model is d is equal to a sine of bt. Now, how is that helpful? Well, what we can say now is that since a is either 6 or negative 6, I'm going to go simple and use just a positive 6. So we have d is equal to 6 sine of bt. All right. The next thing we need to figure out is this value of b. All right. And well, what do we know? We know that the period is 3 seconds. And we know that the period in general is given by 2 pi over b. All right. And we know the period is 3, so this must be equal to 3. So we're going to solve it using this. And what this tells us is that b is equal to 2 pi divided by 3. And let me not skip some steps. So what I did there was I multiplied both sides by b. So I end up with 2 pi is equal to b. And then after that, equal to 3b. And then after that, divided both sides by 3. So b is equal to 2 pi over 3. All right. So since b is equal to 2 pi over 3, well, now we can say, based on these two lines, that d is equal to 6 sine of 2 pi over 3 t. All right. Now, the next thing we got to figure out here is what is the frequency? Well, we already know the period, and we know from up here that the period is the reciprocal of the frequency. Well, this would also tell us that the frequency is equal to the reciprocal of the period. So in fact, we technically didn't have to wait until after we found the model to figure out the frequency, because now we can say that because we've got the period being 3, so since the period is equal to 3, that tells us that the frequency is equal to 1/3. All right, because it's just the reciprocal of it. Let's do another one with this harmonic motion stuff. So example F. Given the equation, so given the equation d is equal to 4 cosine of 6 pi t, right? Notice that this is a harmonic motion or simple harmonic motion. Find, the first question is going to be the maximum displacement. Next, we're going to find the frequency. We're also going to find the value of d when t is equal to 4. And lastly, we're going to find the least positive value for which d is equal to 0. So let's get a visual as to what's going on with this with the simple harmonic motion. All right. So the idea here is that because it's moving like 4 cosine, well, it's a cosine function. Notice that there's no horizontal shift or any vertical shift. So what I can say here is simply that if this axis is d and this axis is t, then this is moving this way. All right. Let's draw that a little bit better. Let's say that it's moving. There we go. Way better now. All right, cool. So we've got something that's moving this way. Notice that I didn't draw anything to the left of it. The reason for that is because over here t would be negative, and that would mean with simple harmonic motion t is time. So there's no sense of talking about negative time for something like this. Now, since this is moving this way, it's asking about the maximum displacement. All right. So the maximum displacement, well, let's think about this. This right here is the amplitude. All right. The maximum displacement is talking about, well, from the center, what is the maximum that you move in either direction? Well, the maximum that I move in either direction from the center is just simply the amplitude. So when this is asking for the maximum displacement, so these are the solutions. So when this is asking for the maximum displacement, it's really asking for the amplitude. So let's write that down. The max displacement is equal to the amplitude. All right. Now we know what the amplitude is, because the amplitude is just simply the coefficient of our cosine function. So in here, we're going to say this is going to be, well, the absolute value of that. So it's going to be the absolute value of 4, which in this case is just 4. So the maximum displacement is 4 units, whatever units we're working with. All right, 2. The frequency. Well, we know that the frequency is equal to the reciprocal of the period. In other words, the period is 2 pi over b, so the reciprocal of that would be b over 2 pi. And we've got the value of b because b is just the coefficient of t inside the argument of cosine, so it is 6 pi. So what we have here is just 6 pi over 2 pi, which is equal to 3. So in here, the frequency is 3. This tells us it's 3 cycles per unit time. So let's write it this way, 3 cycles. Oh, that's not how you spell cycles. 3 cycles per unit time. All right. So in other words, if we were working with seconds, we will be able to see 3 cycles of the cosine function within 1 second. All right. All right, so that's the frequency. The next thing that we had was, I forgot, the value of d when t is equal to 4. So we know that d is equal to 4 cosine of, what was it, 6 pi? Yeah, 6 pi t. And we want d of 4. So it's going to be 4 times cosine of 6 pi times 4. 6 times 4 is 24. So I have 4 cosine of 24 pi. But that's not in the unit circle. So if I come up with a coterminal angle to this, in other words, I'm going to be subtracting 2 pi over and over again, I get that this is equivalent to saying just 4 cosine of 0. And cosine of 0 is 1, so I end up with 4 times 1, which is 4. All right. Cool. And lastly, the last question was the least positive value for which d is equal to 0. So we want d to be equal to 0, which really means that we want 4 cosine of 6 pi t to be equal to 0. Well, if I divide both sides by 4, I end up with cosine of 6 pi t is equal to 0. Now, that's kind of weird to think about it. Let's do it this way. Let's say that theta is equal to 6 pi t. So in other words, I'm going to do sort of like a u substitution, but with theta. So I'm going to call it a theta substitution. So let theta be equal to 6 pi t. We end up with cosine of theta is equal to 0. All right. And well, we want to figure out what value of theta gives me that cosine theta is equal to 0. Well, from the unit circle, we've got the options of pi over 2, 3 pi over 2, but we also know that negative pi over 2 would work and negative 3 pi over 2 would work, so on and so forth. But we want the least positive value. The least positive value would be where theta is equal to pi over 2. So I'm going to say now here that since theta is equal to pi over 2 and theta was equal to 6 pi t, well, we get that 6 pi t is equal to pi over 2. Dividing both sides by 6 pi, I end up with t is equal to 1 over 12. All right. So, and again, that was dividing both sides by pi as well as by 6. So in here, t, if it was in seconds, it would be in 1/12 of a second, where we get the first time that the distance is 0 with this simple harmonic motion. All right. That is the end of 4.8.
Wasn't that fun? If you think I made a mistake somewhere, you're probably right. Tell me all about it in the comments. If you feel you learned something from me in this video, hit the like button, hit the subscribe button, but more importantly, share it. Share this video with your classmates. And remember, you don't have to like math in order to be good at it. But you do have to be good at it. I am Jose Orozco. Goodbye.